so now we're going to go to chapter 2. Now this is something that's going to be brand new. You've never done this in high school. It's called set theory. And there's a lot of vocabulary, a whole lot of vocabulary for this. We have to get used to this vocabulary. I've never had, people who've tried never had a problem with this, okay? There's just a couple things that are tricky, but it should be okay. All right. So, oh, I don't even have my notes. That's all right. I think all these things that go right here are actually these words. So, here we go. So, the first thing is we have to define what a set is, and it's just a collection of objects. Okay? So, you can think of a set of objects is all the things in your car that used to contain liquid. Sonic cups, Chicken E cups. Got anything in your car that has some of those things? Just sitting there? Yeah. Everything in your cup holders. So that's not something. You can say a set is people enrolled in this class. That's boring. You can say a set is the coins I have in my pocket. Okay, so you can have all kinds of things. You just have to define them. Okay, and everything that's in a set is called an element or a member. Once again, has to be well defined. Just use words. Use a lot of words. Okay, and they have to be clearly determined. I can't say coins. Well, which coins? Coins in my desk, coins in my pocket, coins in my car. I need to tell you which ones they are. Okay? So you can use word descriptions. Okay, one way that we do this is use a thing called the roster method. And that's one that you would actually just list out everything that's a set. And you'd put squiggly braces around it. So, Bob, Jane, Sally, Juan. Those four people are set because I just listed their names. Okay. Now, there's probably, I don't know, I've only known one Bob. No Sallys or Janes in school. A couple Juans. Anyway, so you might have to be even more, you have to define them, okay? Or, there's a roster method is really quite easy. Just list them all out. Or, there's a thing called set builder. And we're going to illustrate this one. So, let's say, X such that X is enrolled in contemporary math. We don't have to use X. And remember that, I don't know if you remember this or not from Algebra 2, that means such that X is enrolled in contemporary math. And let's say Bob, Jane, Sally, and Juan are all enrolled in contemporary math. Those are the only four that are in math. So those are saying the same thing. One's a little bit more formal. Okay, so the set builder is a little bit more formal. All right, so here's our set. Sets are often with a capital S. I mean a capital letter. Say that we're talking about a set. Okay, and so this is roster. They wrote them all out. So can you put that in words? What are those four states? What distinguishes those four states from the other 46? No idea. Do you know where they are? North and west? So we say let S equal the four states in the northwest part of the contiguous, is that what it's called? Contiguous contiguous states, contiguous United States. So if you go north and west, you're going to say Alaska, but I don't want Alaska, so I'm going to say contiguous. I think that's the right word. I'm not real sure. I don't teach the English. I try to speak it not very well. So word descriptions are kind of annoying to do. They really are. Because Washington, Oregon, Idaho, Utah, I guess it was in the northwest. Okay? Alright, so here's a word description. Set of US coins with a value of less than $0.50. And we want to do the roster method. So B, capital B, is it, oops, sorry. Capital B. Capital B is everything that's less than a $0.50. So a penny, a nickel. Oh, that's how you spell nickel. I'm not sure if that's how you spell penny. Dime, I'm pretty sure that's right. And a quarter. And that's all I can think of. Okay. Once again, these are really basic. We're just doing the basics of these lessons. Get down some of the vocabulary. Okay. So express the set O, and that is x, such that x is a positive number positive odd number less than 10. So let's put this in roster method. So O is equal, what's a positive odd number less than 10? Isn't it 1, 3, 5, 7, and 9? Okay, now there's one more set that's very important. It's called the empty set. Okay, it means just nothing in it. Okay, so it's represented by two ways. The old school, that one right there. Oops, sorry. That one, or you can do brackets with nothing in it. Either one. Okay. However, don't combine those two, because this is not the empty set. What that is the set that contains the symbol for the empty set. Right? So that's not empty, it contains a symbol. So the empty set is one of these top two. Now, there are some great homework questions, great test questions, really fun, that make your mind go, what? Are you sure? Oh yeah. So your mind's going to go a little crazy trying to figure these things out. Okay? So which of the following is the empty set? Is A an empty set? And so also the tests become true false kind of things. Is this the empty set? Is this not? And I can ask a bunch of questions fairly easy. All right. X is a number less than 3 or greater than 5. Can you think of a number less than 3 or greater than 5? Of course I can. 7. 7 is greater than 5 or less than 3. So that is not the empty set. X is a number less than 3 and greater than 5. I can't think of one. Can you think of any number that is less than 3 and greater than 5? No. So this is the empty set. This one is empty. The word nothing, is that the empty set? Nope, it's the word nothing. It's not even a set. There's no squigglies. There's no definition. There's no roster method. There's nothing there. Okay, and then this one is not empty, right? There's something inside it. It's a weird looking symbol because it didn't transfer right. But that's not empty as well. So, kind of fun figuring out some of these, what's empty, what's not. Okay. There's a weird symbol That means that is an element of. So it's kind of like an E, which helps you remember that is an element. Okay. The symbol blank is used to indicate that an object is an element of a set. Easy, right? So this symbol E is used to replace these words. Is an element. Wait, blank. Shoot. I don't want to mess this up. Yeah, is an element of. And I would suggest while you're doing your homework that every time you see this E that you say is an element of, just for a while, just get that into your mind that, oh, this is an element of. Okay? Now we need to make a symbol that is not an element of. So what symbol would you make? Look at you go. Boom. Okay, so that symbol just means it's not an element of. Alright, so I love this first test. I can ask a bunch of questions, and most kids finish the test fairly quickly because it's just true-false questions. So is 8 an element of this set right here? Yes. So even though it's not listed there, the dots means every number between 3 and 10. You set the pattern, you continue the pattern, you end the pattern. So yes, that is 8 is in there, so that is a true statement. Okay. Okay, then we have R, then we have A, B, C, and Z. Is this true or is this false? True. R is not an element of that. R is not in there. Okay. Now, what about C? Okay, you want to say true, right? Okay. This is a trick question. There are trick questions on this. All right, so if we look at this part, we know what this is, right? So we could actually do this in roster. We could go Monday, Tuesday, ... all the way to Sunday, right? We know that. And then just close that. All right, now look at the left side. Is this exactly inside this set? And the answer is no. This is actually a set that contains Monday. The set containing Monday is not an element of this set. Monday is an element of that set, but a set containing Monday is not. So this is a trick question. Okay, so kind of weird. Kind of weird. Okay. A couple things that we didn't get to in high school, but it's not a big deal, probably because we don't teach that way, and Pearson doesn't teach that way. Okay, so the set of, but you talked about it, you probably just know it already. Set of counting numbers, 1, 2, 3, 4, 5, they're called natural numbers. Okay, and that's what, they start off with in kindergarten, 1, 2, 3, 4, 5, 6, 7. They don't even start with 0 yet. They don't add 0, they don't add negatives. But in this class, we're going to use the capital N. So when I do it like this, I do like that. So you'll see this double, like this. When I write it, it's like this. I'll try to do it capital N or define it somehow. However, it's just the natural numbers. Okay? If you see Z, that is the integers. So that negative, whatever. We'll probably get to that somewhere. I don't know. Who knows? Okay. Alright, so here we go. Some of these are a little bit fun. Set A is the set of natural numbers less than or equal to 3. So what are these? We're going to do these in the roster method. What numbers are natural numbers that are less than or equal to 3? Isn't it just 1, 2, and 3? All right. Okay, so now set, oh, so I should do this as well, sorry. A equal that set. Okay, set B, the set of natural numbers greater than 14. So 15, 16, 17, set your pattern, hit 3 dots, and the pattern never ends, so I'm just going to leave it with dot, dot, dot. Okay, so set O not a natural number, so that means it's 0 or negative, and odd. Odd, so -1, -3, -5, -7. Yeah, so I would do it this way. You probably could do it different ways. I'd go, because -7, -5, -3, -1, and end it. I'm not sure if I love that. Oh well. That'll work. Okay. Okay, so we have 2 more pages to go through. Probably won't get done. It's okay. I'll just finish the thing. Alright, so here's something new. The cardinal number is how many elements are in the set. Okay, but here's the important word right here at the end. Distinct, unique, different. Okay? Yeah, we'll get through this. It's fine. Okay. If something repeats, it does not add to the cardinality. Okay? So here, what's the cardinal? This is really easy. What's the cardinality of set A? Don't you think there's 5 different numbers? And the cardinality of B is 1. And the cardinality of C is, what do you think? You're going to have to fill in the 9, 10, 11, 12, 13, 14, 15, 16. I got 8. Cardinality of D, 0. All right. What about this one? What's the cardinality of that, of E? And this is what it's going to look like. It's going to N of E, capital E. That's what the problem is going to look like. N of E. Well, how many are in there? Well, I can tell you the answer is 122, right? Because if 1 here, the answer would be 123. But we don't have 1. We don't have 1 in here, so it's 122. But how do you do this? What if it started at number like 42, 43, 44, and went to 123. Well, this is a little harder. So what the way to do this, ready, is subtract 123 minus 42 and then add 1. If you subtract these two numbers, you get how many gaps there are, but you don't get the end. You get one end, but you don't get the other end. So you have to add that back 1. So this would be what, 81 plus 1 would be 82. Okay, and there are some harder problems here, and and it's on the final. Do this one. Ready? What's the cardinality of F? And we're going to start at 86, 88, 90, dot, dot, dot. We'll stop at 242. Okay, so now we're doing evens or every other, right? So same type of process here. So 242 minus 86 would be something. Why did I make it so hard? 156, right? But we skipped every other one, right? So we need to divide that by 2 to get to 75, 78, and then add the 1. So the answer to that one is 79. That is actually on the final. Something just like that's on the final. It's on your homework. So, and I'll make a test question with it as well. But it's the same process of the last one minus the first one plus 1. However, it's because we skipped every other one, we need to divide by 2. Okay. Woo! Fun stuff. This set theory is a bunch of stuff quickly. All right. Equivalent. This is going to be a little bit weird to you, maybe. It's weird to me. Equivalent sets have the same cardinality. So if this set has a cardinality of 5 and this set has a cardinality of 5, they are called equivalent. And a one-to-one correspondence. They should have a one-to-one correspondence, and that each thing in A can be with one element in B, and each B is in A, and that's from pre-cal. Did we do a little one-to-one in algebra 2? I don't think we did. Anyway, let's say we had set A, and we had Fred and Jane and Susie. I don't know anybody else's name. And set B, we had red shirt, red pants, and red shoes. Okay? So their cardinality is 3 of it, both of them. They're equivalent. Now, if Fred was wearing a red shirt and James was wearing red pants and Susie was wearing red shoes, then we could pair those up with a one-to-one correspondence. That Susie always wore red shoes, Jane always wore red pants, Fred always wore red shirts. Then that's a one-to-one correspondence. It's cardinality means something more here on this next one. All right, so ready? Here's a nice little problem. Percentage of Americans optimistic about the future for each region of the country. So each region, West, Midwest, South, Northeast. A is the set of the 4 regions. So A would be the West, Midwest, South, and Northeast. Right? And B is the percentages. B is 75, 73, 73, and 68. Now the question is, are these equivalent? Is their cardinality the same? Do you see that the West is, huh? What do you think? So what's the cardinality of this one is, the cardinality of A is definitely 4, right? There's 4 unique things here. But the cardinality of B is 3 because these repeat. So only one of them gets to get counted. So because the cardinality is not the same, then they are not equivalent, and there's no longer a one-to-one correspondence. Like if I said 75 west, but if I say 73, you don't know if that's the Midwest or the South. So it does not have the one-to-one correspondence. Okay. The bell rang. Okay, I'm going to go. You feel free to go. I'm on plus. I'm gonna finish this video. Okay. Okay, I'm back. All right, I'm gonna continue doing the videos. All right. So we're at cardinality, and if two sets have the same cardinality, they're equivalent. But be careful of tricks like this one. That's the same element. Those are not distinct. So this cardinality was 3. So therefore they are not equivalent. Okay. Set A, we call set A finite. I know there's a lot of definitions on this in this thing, and that is true. There's a bunch of definitions in this first chapter, but once you get to use them and start doing your homework, you'll see that, oh, well, these make sense, and I'm okay with that. A finite set, remember, you got infinity, and you got the opposite of infinity is finite. Okay, if the cardinality of the set is 0 or is a natural number, a counting number. So let's say like the number of sand, grains of sand on the beach. It's not an infinite set. It's not an infinite number, right? Those technically would be countable. I would not want to do it. It would take a long time. Probably would not be very accurate, but we could actually count them if we had to. Okay. And a set whose cardinality is not 0 is called an infinite set. Now, there's all kinds of good math about infinities, and are infinities the same length or number? And there's some great debates about that, but that's not part of this class. So all we're going to try to find out is, are these finite or infinite? So here we go. X such that X is an element of the natural numbers, which is 1, 2, 3, 4, 5, 6, 7, goes on forever. And so X has to be in both these things. X is greater than 100 or equal to. So that would be what? It would be 100, 101, 102, ... and it never ends, right? Never ends. So it's infinite. Infinite. Okay? Natural number and less than a billion. So yeah, I think that's billion. Well, we could count those, couldn't we? So this is a finite set. The set of natural numbers less than 1. Well, isn't that the empty set? Because there are no natural numbers less than 1. And what is the cardinality of the empty set? Isn't it 0? In other words, the cardinality of the empty set. Isn't it 0? And the answer is yes, it is. So that's fun. So if it's 0, then it is a finite set. Okay, and then the last definition for this very first part is equal. Okay? They have the exact same elements, same members are in each set. Okay? If these two sets are equal, then they must be equivalent. Right? If they are qual, then they must be equivalent. They have the exact same elements. Alright, so Is this true or false? Okay, so, and the symbol for equal sets is just the equal sign. Not a big deal. Okay, so OLD and DOL, cardinality 3, cardinality 3. O is in both of them, L is in both of them, D is in both of them. Each member matches up, so this is true. They are equal. All right, 4, 5, and 5, 4, and the empty symbol set. Well, the cardinality of this one is 3. It's 5, 4, and a weird looking symbol. The cardinality of this one is 2, so it's false. All right, and oh, sorry, I was off the screen. Hopefully, you're okay there. And then here we go. We got 1, 2, 3, and 4. We listed a bunch of 1s and a bunch of 2s. We didn't have to do that. So technically, the cardinality of this one is 4, as well as this one. 1 appears in both, 2 is in both, 3 is in both, 4 is in both. So they are equal, so this is true as well. And then also you could have the not equal symbol if you needed it. Okay, so there's a lot of definitions in a little bit of time. Okay, and we're going to stop right there in chapter 2, and we're going to go do the first lesson in chapter 3.